Oh, hello. There we are. Now we have audio. How's it going? Hey. Cam's not popping up, despite the fact that it's definitely. Oh, yeah. It's gonna add. It's that one. This one? Deactivate. Why is my camera not showing up today? Curious. It's currently being used by another application. What other application? I really don't want to turn. Android can't. No. Alright, let's. Oh, let's try making it. And a brand new one cannot see this. I'm just trying desperately to turn off my camera. Like, I can see that it's quote-unquote on. The light's on. Just brick. How annoying. seems to be bricked for right now. Oh, can I just delete all of them? Delete this source by doing that. How do I delete an entire source? Shift delete? That is so irritating. Apparently, as of 2020, there is not an option to delete all sources. Alright. That's going to take a hot minute to fix then, because I've got a lot of scenes. So, it's even me. Anyways, unfortunately, no camera today. I apologize. I cannot figure out why it doesn't want to work today. I'll delete both of these webcams and I'll keep an eye on my camera. If it turns off, I'll try to re-add it. Oh, I guess I can just unplug it and put it back in. Oops, sorry. What's the harm in it? Oh. Yeah, no, it's not reappearing. Okay. Well, in that case, listen to the voluptuous sound of my voice. So today is some more work on skill trees. You might notice we're back in Python. It's going to be a lot easier for me to prototype a skill tree system in Python than it would be in VS. Oh, sorry, not in VS, in Unreal. Because in Unreal, I've got to work with the Unreal specific code. In here, I don't have to. So, if I zoom on out, I've written some notes about how I want the skill tree system to work. So today we're kind of working on more how the skill tree is built rather than how it's drawn. Starting to run into issues with how the skill tree is supposed to look. In reality, I'd want to move this up to inhabit the same space as this, and yeah, stuff. I'm getting there though. I think I have an idea of how to work this, and yeah, it will be fun. Basically, the way this is going to work in the end is the only spots that are going to be sort of locked in when I rejigger everything is the base node and the end nodes, and then everything in the middle will snap to the middle of their children. That's going to be the general idea. It'll be fun. Anyways, that's not what we're worried about. I'm going to get ChatGPT to probably do that. What we're worried about today is this. Actually just creating this. Creating the branches. Creating converging points. Which is going to be a lot of math with random chances. And we're going to plug these numbers in. I have no idea if these numbers will be good, but we're going to try them, and we're going to see how they work. What kind of skill trees we get out of them. So these nodes are going to be... So the nodes are pretty much skills. Self.power level. I guess I can just do... What I'm going to do is I'm going to hard code this. Actually, what I'll do is, in fact, just change this to a power level. There, and then this is going to be a string power level. This is just power level. Because some of my math is actually considering the level of power. A lot of my math, you can see here, actually. So current power divided by the average of the past 3 power levels. So you can see here, for example, if this node was a power level 1, this node was a power level 0, and this node was a power level 0. That's not how that works, sorry. If if it's a power level 0, it means it doesn't exist. So if we are here, we're on the first node, and we're looking at this node here, like, sorry, that's not how that works either. If we're on this node here, what we do is we look back on our history, and we see no node, level 1 node. And we ourselves are level 1 node. So my chance of splitting is going to be 436.5%. Splitting is kind of a strange description. It just means a node is going to be placed. This node could also be a converging node, which basically just, instead of being its own node, it's an empty node, and that node will then be replaced by a neighbor node. So if there is a if there is no neighbor nodes, or the only neighbor node accessible is one of its own, it will just ignore itself because it's attaching to a node that it's already attached to. And that's going to be my way of sort of re-narrowing the branches into separate ends kind of deal. I'm worried that this will instead just... it should be fun. We'll see. We'll see what it looks like. I want to see what this comes out as. What we'll do is when we get this actually coded up, we'll actually even draw out the entire tree. So, now we have a power level. This was all auto-generated. But it looks like... some of this is fun. I want the right to file. I don't want the add node. I don't have this yet. So this would be the ideal, like, if you took all of the numbers of each power rating of each skill, that's what it would look like. But for now, I'm just going to say Um, how do you generate that kind of graph? It would be it's kind of a sine wave. It's not really a sine wave at all. It's a bell curve, right? Yeah, it is. That's what I'm looking for. Actually, a bell. E equals negative x squared, apparently. Take a look at that in Desmos. So this is actually the equation for how I calculate what the chances of a convergence is. So as you can see, before like 2 nodes, there is 0 chance, and then finally at 3 nodes, we get a possibility of a convergence. Anyways, so negative x squared, is that what I remember being? How do I do a squared? Negative x squared. Yeah, that's sure, isn't it? Negative x. Oh, wait, no. E to the power of negative x. Power. I used to remember how to do this, I swear. Is there not a button to go into, like, exponent town? Oh, is it this? No, that literally just moves backwards. Flex mode? Ah! That's a good point, actually. Where is symbol? There. The power of negative x squared. There it is. A bell curve. So what I need to actually do is move this bell curve over. Does that just work? Nope. Oh, is it... Nope, that increases that height. That would be what divide by 2 does. How do I move this? Square. It's 2. No, I want to be up here. So what happens if I do... That's a fun one. Also, what's positive x? Okay. Okay, how do I move right? Just doing some quick Google searching here. A bell curve. Increasing the mean. Seeing a lot of not what I'm looking for. What's this then? There we are. Bingo. That's about right to me. How do I make it less pronounced? No, I think that's okay. All right. What the heck is E in this? What does E context? Euler's number. Mathematical constant equal to approximately 2.71828. Where? 718. Good to me. So, scores? I think it's like... No? It is 2. $200? I have to draw it. 50. I don't think I need a mean. Use a... I'll just say a bell curve. we are. We're good. Where'd my graph go? Nodes 50. Oh, that's a good point, actually. If we look at this, we go from X. If we think about this, what we're thinking about is the chances of a node spawning. So for ease, we'll say y is the chance of that specific node spawning, and x is the number. So I actually need this to be much wider. How do we do that again? Times? Is it multiplication? Nope, that's scale. Addition. Nope, that's height. Down. What happens if we divide? Doesn't get less harsh. No, it doesn't. There we are. Divide x by 2. 3. Five? That looks about right. Right there. Okay. This is a weird math. Euler's number. So chances equals oh, n. Now 10 chances at I is equal to int Euler to the power of negative I, which would sorry, one moment here. Sorry if you couldn't hear me there. I really like this distribution. That's what I'm going to stick with, because it means that the highest tiers have the lowest chance of appearing. And I think that's a good idea. Now I'm going to actually generate the nodes here. That's... No. Choice? Random choice. Oh no, it's gonna be choices. From 1 to 10. Yeah, that makes sense to me. Including 1 and 10, that should be fine. Yes. Now we print... Oh. Now nodes append node at power level. Let's print the label. Apparently that does not work. Am I stupid? So what happens if I do 0 through 10? I see no zeros. Is it not inclusive? Nope, there's a 0 there. Okay. That's fine. I actually like this distribution more. Number of weights does not match the population. It said 9. For iron range 9. Oh. I see no 10s. I've not seen a single 10 so far. Interesting. So... says inclusive here. Oh no! Stop is exclusive. God damn it. This was correct. You know what? We're... Come on. Oh, I saw one. There's a 10. We shouldn't have any zeros either. No, we won't have any zeros. Hallelujah. All right. So now we have power levels. And let's actually graph it. Oh, if only I could remember what the graphing one was. What the graphing library I always used was. Look for... No, I'm forgetting what the game is called. GTFO. I'm looking for a GTFO weapon calculator here. Am I blind? Yeah, I don't have a GTFO weapon kill. Just weapon kill? That's not at all. Oh. Weapon tech. Where the heck is my GTFO weapon calc? That's definitely not where I want to be. Yeah. Oh, GTFO efficiency calc right here. Matplotlib. This is not a very big sample size, so let's do that. Let's do even more. There we are. That's more of a bell curve. Yeah, I think this works. Why does this not exist anymore? Oh, whoops. All right. I'm not going to do this anymore. That anymore. Tree equals skill tree nodes. There we are. So now we have all of the nodes and their power levels inside our skill tree class here. So now what we have to do is actually build the tree. All right. And of course, so it's always going to start with a base node for now. The base node just... The base node is going to be nothing, and then the base node can branch into X amount of nodes. Yeah. I'm still on the fence. Because currently, what's going to happen if we take a look at my whiteboard here again? Whoa. Wait, does that work? Oh my god, it does. That's huge. So, this chance of branching, when you're at the real start of this, it's 436%, which is guaranteed 4 branches and maybe a 5th. I am sorta thinking that if it's a 100% chance, then we roll, and if it gets a 95% hit, then we do create that branch. So, like, 100% chance isn't 100%, right? So, let's change... No, we'll leave it at 150 for now. So, we start at the base. While self.unsorted nodes. What does this even mean? It just means that there's stuff in it, I guess? Not the fact that the list exists, I hope. Actually, no. What we should do first is roll to see how many branches. I guess what we should do is self.dot. Really loose cable. Okay. I write in blue whenever I'm going to delete it later, probably. Or if it's an illustration, or if it's a note. I write in blue a lot, and it means a lot of different things. Now, do I roll for all branches right away? No. No, I don't think so. So, what I want... That calculate depth is going to be useful later. Roll for a branch. If we branch, then we then we generate a node. Then we enter that node. And we turn to the start. Turn to parent. Oh, actually. Guess this would be 0. So if our parent does not equal done, then we roll for branches. Else, if node. If the node does not equal done, we roll for branches. If we branch, then we generate a new node and we enter that node, and then we generate branches off of that node until such a time as we hit the not, in which case we will then return to parent and then check if that parent is done. And if not, then we roll for branches, and then it just expands. This might work. This also might be a mess. We'll find out. Shall we? Okay. Well, dot done. So the chance equals oh god. So I'm actually going to write it in here so that we can actually enter these nodes and do it from here. This feels wrong, but I think it's the the cheese in the moment that feels right. So now we have to calculate the chances to branch. Oh, this feels wrong. Actually, this is wrong. I'm not going to do it in here. Bye. I'm sure it'll be fine. Chance equals... where's my... I guess it would be down here. Right here. So. Equals 1.5 times the current power. So it would be self dot root. Ooh. Actually, this is what we're gonna do. This is what we're gonna do. Node self root, and well self dot node. Sorry, not self dot node. Well, node dot done. Well, not node dot done. We roll. And if no, then if node dot parent else do that? Does that sound right? No, we shouldn't have to do this. We shouldn't have to do that. If node.parent actually, what I can do is actually outside of this. Well, not. And then close there. If node.parent exists, then node equals node.parent. This is backing out of a out. Okay. That's happening when we're done with a node. Yeah. Yep, that makes sense to me. All right. So let's calculate the chances now. So chances equals 1.5 times the current power, which is node dot power. dot power level. Oh. So what I'll do is I will make a focus node. Parent. Actually, no. So for 3, if focus node dot parent, we add the power level of the. Yep, looks good to me. And then parent advantage average. I don't know why I spell it ADV, but average is equal to the average divided by 3. So this divided by the parent average. And times 1. What just happened? Times 1 minus the percentage full. That's something else I add here. Max size equals. Well, we'll just say the max size is 50. There. Yeah, you're good. I just wanted to ensure that you could. You can. I'm gonna readjust my cable real quick. One second. There. Better. All right, let's try this again. The one minus self size divided by that. No, it should be the other way around. Oh. Blend of self.nodes divided by the max size. And now I'll just write this down real quick. Divided by average parent power times 1 minus the percent complete. There. If, so this is returning a number between 0 and 1, if I remember correctly. I don't know because it doesn't actually tell me. I think it doesn't, actually. No, I think it does. I think it does. Okay. Yeah, in creation, we're going to need to add the node to the nodes. What's this? Oh, we don't need that. No. Oh, that's a good point. Now we need a decision. Does it go up in power or does it stay at the current power? The way I was going to do this is actually doing a roll against okay, the way I'm going to do this, if we branch, we generate a node. The power is equal to the parent power unless no more of that power, or I was going to do I'm gonna mutter to myself for a little while I think of this. The Okay. So that's how this is going to work. if you could follow that at all. All right. So the way it's going to work, I'll just drag this up here real quick. We're going to look at the previous 2 levels. Or sorry, previous 3 levels. And we're going to look at the difference between them. Lies by up here. So if we've had 3 non-level ups, then it's a guaranteed 1. It's a guaranteed 1 because we're going 1 minus 0. If we've had a level up already, then it's only a 50-50 chance. If we've had 2 level ups, then it's a 0% chance to get another upgrade into the next power level. That way it's not just a string of just really powerful upgrades going up and up and up and up in value. Okay, now to translate that jarble into code. Down here. I guess I could do more than that, though, actually, now that I think of it. I'd also do the difference between my level and the previous level. Let's do that as well. So if dot parent, then it's the plus equals the focus node's power level minus the parent's power level. And we focus on the next one. So now yeah. That looks good to me. Yep, that looks good. So if we do this and there's no node left for us to go to, then we can't draw a new node. So we mark it as done and we exit out. So if the random is up, then we don't. Then we just don't power it up. And if we aren't branching, then we just set it to done. Now, that should exit out of this while loop, because now the node is done. So now we say, okay, if we have a parent, node is now equal to node.parent. And then we go back up here. While the root is not done, go back into here, and we check if that node's done. If it is going to be done, then we go right back out of here, and then we go all the way back up to the parent. This looks like it might work. I guess we'll find out. This is not going to work. So we're not doing calculating depth yet. We'll do calculating depth somewhere. I can't remember where I actually cared. Yeah, I cannot remember where I actually cared. Okay. This is going to be so hard to read, but sure. What's the file name going to be? Skilltree.txt. Apparently I did worry about that. Oh, skilltree.txt exists. It doesn't, though. Well, let's find out why not. Oh, I'd never built the freaking tree. Lol. We'll do that up here. There. Job done. Oh. Error. Divided by supported operands, string, and float. Oh. No, this should be an int. Power level is set to base here? Oh. Do I want power levels? That makes sense? Sure. Division by 0, that's what I was worried about. Yeah, that makes sense, actually, because I'm dividing by the average, so this has actually got to be a 1. Oh, was that a crash? Yes, it was. Node power level, which is 1, divided by the parent average, which is 0, because that makes sense. Because the parent average is going to be 0 plus 0 plus 0. We'll set the chance to 1. So it's just the power level divided by 1, which is just 1. Which makes sense to me. Another division by 0. What, max size? This should never be 0 now, because if it... Oh! Oh, that actually ran. 1 to 1. Alright. So let's jump over this real quick. Chance is 1.47 right now. That's a lot lower than I thought it should be. 1 divided by 1, which is equal to 1, times 1 minus... And here. Power level would have been 1. Divided by the average, which is... So this is 1, right? Times 1 minus the length of the nodes, which is currently... Divided by max size, which is... That bracket divided by 1 should just be equal. One times 0.9. 0.98, of course. That does actually make sense. What am I forgetting? Why did I get 400%? Why did I get 400% here? Oh, because this is such a low number. Oh. That'll do it. It is running. It appears to be broken, though. Oh, I just killed my bot. Oh, well. If anybody wants to do TTS, let me know. This is not the correct one. That's why it's broken. The 147. That's actually huge. We'll try 0.1. Actually, 0.5. That sounds better. Well, one. It exists. All right, let's step through this and find out where it's getting stuck. All right, so the chance is going to be equal to 2.94. That sounds perfectly reasonable, but an equal chance of getting 3 branches off of the base node. So power up chance. So now the power up chance is going to be 0 right now because we haven't actually got any parents. So they should all be 1. So options is... Yeah, okay. That's good. Oh, is it because there's only 2 level 1 options? It's just because there's not enough skills here. Lots of 1-to-1s. I just want to see it actually do literally anything other than 1-to-1. See if I can get that. A lot of 1-to-1. Maybe I have to flatten it a little bit. Or I make it wider. That might actually be the play. Instead of a bell curve that gives very few level 1s, which in hindsight is a very poor idea if I want to have a lot of branches at the beginning, then unless I want to do 2 bell curves, but I don't want to do that. I want to have lots of options at the start that's tapering off at the end. So let's do this where instead I'm going to... Oh, also, I completely forgot. When I do this branching calculation, I'm not taking into account the children. So... minus... length of children. Mode. Yeah, because that's minus 100% for E. Sounds good to me. Random dot less than or less than chance. Okay. There. It's gonna fix it? Probably not. Nope. Okay. So yeah, what I'm gonna have to do is actually change up this code here. So instead of having this bell curve be here, what I'm gonna do is I'm gonna actually move it here and extend it a little. That looks good to me. That's lots of ones, up to 4s, and then it starts tapering down. So -1 plus... Oh, this is also to the power of 4. This is still to a power of 2. Let's see what that looks like. Well, let's just take a look. Lots of 1s. It's not leveling up yet. Let's step through. Okay. 2.94% chance, or 2.94 times 100% chance. All right. Power up chance is going to be 0. Right? Yeah. So we create a branch. Now, focus node.parent is the 1. Yeah, okay. Okay, now we take a look at this average. Average is going to be 0.33, I believe. 3, yep. And now the chance is 4.32 to branch. Be a lot. It's going to be a lot of branches right at the beginning. Like a metric crap ton of branch. I might do another bell curve. I might have to do another bell curve to keep this in line, because that's a crap ton. All right, let's take a look at this. It's not going to be the same bell curve as this, because this is way too many branches at the beginning. So let's make another. Can I hide this? Yes, I can. So let's start with this. But instead, let's get that away. This will just be the percent chance of a branch. So without a shadow of a doubt, this should be times at least 2. Let's do it 3. That's gonna tighten it up a bit. That's way too. Two looks good, but I think I have to tighten it up. Let's go up. No. Let's try 1 point. Two. This is starting to look good. I, in fact, think this would be better here. Yeah, that looks about better. A little bit better. Now... that kind of looks good to me. That does actually look quite good to me. A little bit of just numbered jargon, but let's do it. So, chance is going to be equal to yet another bell curve. Keep punching my microphone with my other microphone. Where's number? Power of negative 1.5 plus x divided by, say x. No. Oh, right. Oh, what would that be? Is it just going to be my own power level? Guess it would just be my own power level. No dot power level. I don't actually need that anymore. Sorry, power level divided by 3. That's that. Power of 2. No. Next one is 2. And all of this is times 3. To have up to a maximum of 300%. So. Take a look at this now. Step over, let me see this chance. 76912. So if this is Mr. Elfman, line 27, that list is what you expect. It's just a reminder to me. That's it. That's exactly just to remind me that it's meant to be a list. Making sure my mic is still plugged in. So I'm going to have to make sure that it's at least a 100% chance. Also, this is very just solid. This is very rigid. Which is not what I want. So I'm going to have to add a little bit of random noise in here. He thinks. First things first, if it's a root, if it's a root node. If node is equal to self-direct. Also, equals random dot random int between 0 and 3. 3 sounds good. And then this. Oh, did I accidentally? Good. I guess this isn't super rigid because there's still a chance for it not to branch. Okay. This, I actually have to change this. I have to change this graph here. This should actually be above 1 for anything. Sorry, it should be above 1 here. So 4 branches, anyone? That's the easy way to do it. Yeah, let's do that. That actually lines up perfectly. Yeah. That actually means that I don't have to do this anymore. Of course. But then it's pretty much guaranteed to be 1 branch, so I'm not going to do that. I'm going to leave it at that. Okay. I should also increase the chances of it if we don't have many... Like, if the size is small. Okay, let's take into account how full the tree is then. So let's do plus self divided by the size. I don't coverage out of here. Focus node any. There. That should include the idea that if we don't have a lot of the tree built out yet, we should be branching more often. We'll see if that works. And if I want to, I can always just, for future reference, I'll do this. Sorry. Should be like so. And I will just change this if I want to have a multiplier to that. I want to scale that up. Okay. I'm going to hit play on this. It's not going to really do much. A lot of ones. Oh, is the skill tree still super, super big? Yeah, it's 500. Alright, now we're running into an issue of it not wanting to power up. Or is it an issue of... Yeah, that's the issue. It's not wanting to power up because, I guess... Oh. it doesn't matter how many ones we put in. Let's make it so that the more first level skills that are in there, the higher the chance of a power-up. Because currently, all that matters is like that branch. What we should really look at is current tier options. So let's take a look at how many we've got left. Scale it based on that. If I do that kind of... I want this, but in reverse. I can get that. That. One. That is actually incredibly close. What about negative? Okay. That is incredibly close. Kind of. Oh. I do that. That's actually kind of what I'm for, but I need to look. There. That way, the closer we get to 0, the higher the chance, and it ramps up something fierce. So... up to here. I have no idea. So we'll do this. That will be the additional chances of power up. Plus, of options. Oh, I spelled this. Divided by. So that would be X. Bracket this so that I have some separate. Close the brackets. -1. That should ramp up depending on if we start running out of options. Division by 0. Actually, yes. Else. Power up chances. That's what I want. If the length of the current level options is equal to 0, then power up chance is equal to 0. We cannot. Oh, sorry. Power up chance is equal to 1. Meaning a 100% chance that we're going to power up. Otherwise, we randomly see if we're going to power up. Gasp. Gasp! We actually have a skill tree, kinda. So I notice, I think it just kind of dies at 5. Because I can't get any... I guess it doesn't level up. So this needs to be toned up a little bit, I think. So the power-up chances have to be toned up. Let's increase the chances. I want to see what the chances right out the gate. Power up chance is 0. That's a 0.9% chance to power up right off the gate. That's really low. Let's continue. Should be the next node. And that's also a 0.9% chance. Power up. Oh. I'm completely recalculating. No, I'm not. I actually have it there. Let's try this again real quick. Power up chance is currently 0 because the parents have nothing to offer them. One equals 0. Am I doing this calculation wrong? Then it's... I might be doing this math wrong. A second, sorry. Average. I am doing this wrong. So, equals the power-up chance divided by 3 minus, 5. I'm gonna this. What's that? I want to see what the power-up chance is at each of these stages. Power-up chance is currently equal to negative 0.5. That makes sense to me. Very, very low chance to power up because we're going from a base from 0, 0, and 1. Is it? Let me recalculate here. I'm kind of surprised I didn't get a divide by 0 here. No, because its own... This is not... correct. Oh! Right. Else... do... power-up chance plus... the focus power level minus... No. Just the power level, I think. Because if it doesn't have a parent, it means that this node is trying to go into the nether region. So we'll just go that and then break, so we don't just add infinite. That seems better to me. Let's find it. I'm right. Power-up chance here is negative 0.166666. Yes, that makes sense to me. So, low chance, zero chance of upgrading. That's fine. Here, though. This would technically be 0. It's a nothing node. This should not have equaled out to being... This doesn't make sense, because the current node... Current node has a parent of power level 1. So it should have been... So that's 0... Actually, it's right, because it's wrong. Oh, is it because now I'm doing 3? Is that the issue? So what if I do... Wait. Happens if I to a 0, 1. That would be a 6, 6, 6. Okay. Other way around. Let's give that a shot. Power up chance should be okay. It's a low power up chance. That's okay. And then the next one is no, it's still a low power up chance. Oh, this one leveled up. This one did power up. There's a 0.5. Big. Again, still getting... Oh no, we made it to 7. Oh my god. Way up to... Let's try dropping this back down to... This is actually pretty freaking cool. So now I actually have to make it so that it prints out in a reasonable way. A root. Okay. So that's awesome, actually. It's not perfect, but it's getting there. It really is. So what I want to do now is... Oh, this work? This just work? Unlikely. It's supposed to... Explode. Thank you. Well, no, thank you, freaking co-pilot. Thought that that was going to be... This looks kind of... So one gives me access to a level 2 node. To another... Assist. Copilot, help me out here. We're at root right now, and we have two options. We can either go down a 1 path or down a 2 path. Apparently, this one rolled the dice really high and got a upgrade right off the bat. Let's go down 1. And now it only has 1 branch, so we go down here. 1, 1, 1. Oh, it branched again. Way back to root. There. So now, let's draw this out, because why not? I don't have a reasonable use for my time. Root. I know. The root has... You know what? No, we're getting out of here. Calculate, not neighbors, sorry, calculate width. Don't know what this does. Turn 1 plus the sum of calculate width child for child and node dot children. That's not what we need. So what we would do here is we would back up. We would look to see how many children this node has. Width equals 1. While focus node dot. Actually, what I will do zero. So what I'm going to do is we're going to say dot parent. No point in being in myself right now. So we'll say while focus node dot children. We'll say width is equal to the length of the children, which is correct. Plus equals length. And then focus node will then be equal to focus node dot parent. And then we will say the depth plus equals 1, backing up. Goodness, this is actually very confusing. No, it's screw it. I'm just going to draw it. I want to know the depth because I want to make it look pretty, but it's not actually that important. All right, we're at root. And we have a 1. 1. Let's go. Which just gives me a 1. That gives me 2 branches. A 1 and a 2. Nope. They're both 1s, sorry. I lied. Going up. First branch, that gives us a 1 and a 1 again. Two and 2. Top 1 gives us to another 2. This gives us access to 2 2s. This gives us access to 3 3s. I need to increase the chances of it leveling up. Wow, that's a first triple branch that I've seen. My squares are getting smaller and smaller. Wow, that's another triple. Oh, and that's the end of that branch. Does this one keep going? Yes, it does. Yeah, I really have to level. I have to increase the chances because that's a string of 1, 2, 3, 4, 5 level 4s right there. Wow, that's a triple right there. Five, 5, 4. Okay, 5 doesn't go anywhere. 2 does. Goes to another 5. Wow. That goes to another 5. Okay. Oh, this 4 actually is a bro. No, it's not. What I did was I typed in 4. 3. goes to 5. Nope, that's as far as that goes. Okay. That's pretty good. So far, that is really nice. I have an entire skill tree that's been kind of mapped out for us. We don't have converging yet, but this is already pretty cool. I think the issue is going to be when we go back down all the way. I can do like a pseudo depth meter. Probably going to be a good idea. We'll say depth. This equals depth. Depth plus equals. I didn't. Is that how that works? I actually have to do. At 2, depth doesn't. Alright. Cool. Now I can explore that with a better idea of how deep into the tree I am. Alright. I think increasing the odds of getting like a level up is also going to mean that these branches are like the first branches aren't going to be as long. The other branches will get a chance to grow. We have to weed. Okay. So it's this here. If I increase this, it means that there's a higher chance of level ups earlier with fewer items. So, say I put this as 0.75. Then yeah, we're going to do 0.75, I think. Try that. Okay. Now we get the fun part of having to draw this out. Okay. Start here. We're at depth 0. 2 branches. Level 1s. Three. Depth. So I can see at depth 0. Four, three. Really? 6, 5. Six. Still an incredibly deep. Oh, there we are. So this is the end of the line for that one. So here, take a look at. That's the end of the line for that one too. The end of the line for that one. Wow. Oops. Whoa. Go back down to the 5. Nope. That's the end of the 3. That depth 5? Yeah, okay. Wow. Do I not have a lot of... I should have plenty of 6s. Oh, maybe it's because they're not ending fast enough. Which is an issue that's going to be fixed by these lines terminating into one another. Is 3. It's nowhere. Back to 2. That goes to 2, 2, 2. I have a sickening feeling I know what's going to happen to this branch. Oh no, I did get a 3. Or does this... Okay. I'm dumb. Back out to this one. Oh. Yeah, so... Oops. Anyways. So, as you can see, this top branch went forever, but all of these side branches starved very quickly because they just didn't have anything left. That's an issue of them, A, not being able to level up fast, and also not having many skills to pick from. This is 50 skills, though. I don't know how many skills I plan on having, but I plan on having not, like, hundreds. Like, I'll have passives and stuff that'll help sort of fill up the skill tree a bit, but... Oh, also, this... Do I ever use this? Yes, I do. Okay, max size should actually be set to the length of... No, it should actually have its own... max size equals 50. There. Now I can set a max size. That will also actually help if I have a maximum size. Down here, I could just say max size is equal to... This won't help. Now that I think about it, this will not help. I'm just going to set it to num nodes. The only way I can think of doing this is not doing it where I'm growing out one branch at a time, where I'm not growing out this top branch. The only way I can think to fix this is by going layer by layer. And when I spawn both of these, I do this one, then I do this one, and then I make a list of the children nodes, which would be all of these, and then I do all the children nodes, and then I make a list of all their children, and then I do all those children nodes, and rinse, repeat, rinse, repeat, rinse, repeat. That will probably stop these from being so lanky on one side and just dead on the other. I think that's probably actually the best way of doing this. So, when I build the tree, I no longer am going to do all of this random crap. That's not entirely true, actually. We will be doing most of this still. The option... Actually, most of this is fine. It's... Yeah. It's this that I have to change. Both of these while loops have to change. So... self... self... Not self-done. Yeah. Wow. Stop that, please. I don't have to do this anymore. Why are we returning it? Okay. Now, we go into this node and we say, oh yeah, we check if the yada 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 yada. What we will do is we will say, it's really poor naming convention. And then done. So when we go, so if we decide we're not branching, then we don't do anything. We just continue. If we decide we're going to branch, if we power up, then we choose a random choice. We add the child. So what I'll do is actually I'll say while... What I'll do is I'll say up here, while random.random is less than chance. We can remove this now. Might also have to remove some of this. I don't know yet. Might have to remove this check here. We say while that, and down at the end here we say chance equals 1. That reduces the chance of branching again. So node self.unsorted nodes, that self done, append the else we just done, which is fine. I don't think we're going to end up using that because we're not traveling through tree. Yeah, we're not traveling through the tree in such a done. This else statement makes sense. Not done equals done. That again. This might just work out of the box. We will have to see. Well, I can already tell that something is amiss. No, that's not a miss, actually. It can level up right off the gate. Okay, real quick, I just want to see what the skill tree looks like. Oh, actually, I could have just root code. This looks a whole lot better. I think I still need to increase the chances of it leveling, though. Or just increase the number of nodes in general. Oh, also, if... Actually, there is one thing I can do. There is one thing I can do. If there is... Let's actually do something here. If the current level options are 0. Oh, if the current level options are 0, we already level up. That's not the... Why weren't we going... Did I just get unlucky with the... Seven, 8, 9, and 10 got 0. I guess that's just the issue right now, is that there's not enough nodes that there is a fair enough chance for 7, 8, 9, 10 to exist. Try increasing the number of nodes up to 100. Now we have 1, 7. Okay. So let's take a look at our chances here. Which would be this one, but instead of this, it's times 100. But that's just harder to... So, what I think we do instead... Oh, would this just times 10 be better? Would that be a better distribution? Not really. Alright. I think it will help a little bit, because now the chances aren't going to be quite so high in the middle. But what I think I'm actually going to do is lower that. Can I broaden this somehow? I think I can. How is it that I broaden that? 6? Wow, I was at 2.5. This isn't the right number. I think. There we are. We actually got all the way up to 10. Look at this. Holy. Let's, this real quick. So... 2 and a 2. What I'll do is I'll just do the bottom and the top branches, if I can get away with that. That, I believe, is the first time I've seen a 4 split. Are all 5s, too. Wow. Okay, this does not go to 10. Ah, crap. Well. Okay. I foresee a little bit of an issue now with this much branching. I think I might still be running into that issue where the first rolls are going to starve anything subsequent. That was a lot of skills of the 50. This, actually, yeah, that's actually a really good idea here. This is 1, 2, 3. Six. This is over 50% of the skills in branch 1, and all of these branches are supposed to exist. So, yeah. Should we lower chances here? Maybe we should lower the chance of branches. That would be this one. Max of 4. I think we try and tighten this a bit. That's... Yes, and then... Oh. It's just the exact same as what I just had. No. Difference between these. This is not what I meant. Sorry, I'm at 1.5 and 3. Yeah, that's the one. Power of 2 to the power of 4. Or times 4. Also, with a reduction in chances depending on if we're really close to the end of the system here. I'm gonna dupe this. Let's see. No, I want to set 2 and change what color? Oh, I changed the color. Ah. So that makes 5s basically guaranteed to have 4 branches. Oh, that's another thing, is I can add some random variation here. Minus random dot... Actually, no. What I'll do is I'll do it here. Uh, and is less than 9. Small chance to not branch. With percent chance. 0.95. There. And also we're going to tighten this up. Which I think is what we're actually doing here. A little bit too much. I think I prefer this. Yeah. Yeah. 2.75x over 2. I opened up a monster and never drank any. All right. Oh. There we are. That was weird. Wow, that's not right. Heck did I do? Did I lower the chances over here way too much? Apparently I did. Never mind. It's a 2.5, maybe. Just no chance over here. Let's try this. Okay. We're back up doing 10. Yeah, it's very hard to read this as just this. I can actually write a bit of a code here to have like the bottom tree and the top tree. What I'll do is I'll just say 0 for children in no. we'll do the same old focus node. So root. While there is children, focus node is equal to the 0 index of the children, and we at depth. Bottom depth. And then we take from the bottom branch. All right. Now that is being printed. Okay. So we have to get rid of it. No distribution. Top branch depth is equal to 0. Am I not setting children correctly? No, because I could still explore. Sorry. I'm confused why this doesn't work. Oh, why am I calculating depth here? Get out of here. Top branch depth is 1 and bottom is 5 here. Okay. I actually know a way to fix. So let's just okay. Now we can actually explore tree. All right, top branch depth is 1 and bottom branch depth is 1. All right. What? I see. You're not wrong, actually, computer. All right, so there is a little bit of an error there. 0 level. I think I'm going to do my thing of... Yeah, that's also a skill tree. Alright. So why is that a 0 length tree? Who had access to 2s? 3, 3, 5, 8, 6, 10... So many 7s. That one actually generated a proper skill tree, though. 1, 3, 2. Wow, this is awful. Generated a good skill tree, though. Top branch depth was 4, bottom branch depth was 3. Really? Yeah. It must have been one of these. Yeah, the next branch down. Okay. Should I make it? Okay. There's one thing I can do here, and that's these chances. We can actually change this a little bit. And now, for each node, once we choose that power level, choices at power level -1 is now going to be minus equals... I don't know, 1, sure. Everything else... if chances are at power level -1 equals... Oh, wait. If I equals power level -1, continue. Otherwise, we add 0.1. That would do it. Yeah. In fact, I think I'm actually just going to subtract 0.1 from this. I don't want to go too hard on it because I still want that bell curve. That's a bit better. Six. Let's do... And instead of writing these... I don't want to live in the world where I have to wait for that to fill out. One second, everyone. I will be right back. There might be something I have to do. am back. Alright. So, I thought I had it while I was outside. Let's... Yeah. Let us say if when we do this skill tree, and we say build tree, yeah. For iron range 3, we're going to self.tree. We'll say if self-build tree break. Else self nodes is equal to the root, and self failed equals true. Self unsorted nodes is equal to nodes. Yep, looks good to me. So this is going to try 3 times to build a proper skill tree. This build tree is going to fail if length of nodes is equal to it's greater than or equal to the length of self.max size divided by time, let's say times 0.8. So So basically, if we do not use at least 80% of the tree's available nodes, then we know we failed somewhere. And if we fail enough times, then it's just going to mark this skill tree as failed. In which case, down here, we will rerun our rolls. we haven't generated the tree yet. Oh. I guess there, and then we can it's back. But we can still see the node distribution. Failed. Num attempts goes to there. Else we break. Then if tree failed, we're out here. And we exit. Okay. That should ensure that we get... Because that would be 30 attempts. 30 actual attempts to generate a proper skill tree. So if we go back to 50 nodes. Why is it node distribution? That's not a correct node distribution. I don't know why that didn't work, because I could see that it actually did work. And if I go to skill tree, yeah, this is an actual good skill tree. So I don't know why this node distribution thing didn't work anymore. It should be able to modify it and then be available outside of that loop, but whatever. Anyways, so that's now remedied. Okay, we are going to do one more thing, and that is create the ability for convergence. So anytime that there's a branch, we're going to check if we want to instead converge. And converging happens more often at the end of a skill tree than at the beginning, which is what this one is? Or did I even write it? I didn't. Where is it? Here. Ah, this is the width. So basically, what I need to do is actually be able to tell how wide tree is at any given point. Which is actually quite easy. Believe it or not. It doesn't really matter. I don't think we're going to bother with the width issue. I guess we're just going to have the possibility of an incredibly wide skill tree. If that happens, I'll just reduce the amount of max branches that we have. But if you can see on my little drawing tablet here, I am saying width and taking that into account. The issue is that when I'm doing this, it just means that the skills close to the bottom of the actual tree, because you have to think of width as just how tall this would be. I'm thinking of width as how many tall these slots are, these skills. Because of the way we're doing this, and I can't even really think of an easier way to, or a better way of doing this, the the slots down here are going to have a much higher chance of becoming a converging slot than the slots up here. Just because it's not as wide up here. And there's not really a way of doing that, of fixing that right now. I can think of one way, and that is going back over all of the generated nodes and randomly selecting a few to become converging nodes. I could do that, actually, yeah. And then just do a curve to dictate whether or not we have convergence like this one here. Okay. Let's do that. Probably not a bell curve. Though, I guess a bell curve wouldn't hurt. It's just going to be a bell curve that's way over here. So if we... Now... So the merging happened. Oh. Yeah, sorry. 0.5 actually. Yeah. No. We'll do 3. That looks good. That looks good to me. Up to a really high chance of converging. Sounds good to me. Converging should only be available... okay, so the converging also has to have a maximum of the amount of parent nodes. Okay. So. Nope, I'm doing this in the wrong place. There. Yes. Oh, sorry. No. Chances. No. This equals... power of negative 2.75 plus yes. Node power level or just average, maybe? Oh no. This should be like the percent full. That's what this should be. So wow, I spelled that awful. Oh, 3. The power of 2, power of 3. While actually, nope. No, 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 no. Nope, 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 nope. Converging needs to be equal to less than 1. Or sorry, 1 less than the total parent nodes available to the current not dones. In self dot, no, self dot self dot done. I do have to do this because keep in mind of the if node up not in if of available is less than chance is equal to length of parent nodes available minus 1. That means that if there's 2 parents, I'll draw this out here. If there's 2 here and we can't, and we have this sort of setup, even if we have this sort of setup, we can't have more than 1 converging node because this converging node will just turn it into this, and this converging node would turn it into this, and this converging node would also turn it into this, because that's the next closest one that doesn't have a shared parent. Yeah. I've now got this sinking feeling of what happens if we do this. And this one becomes a converging node. And I think the way I'm going to fix that is literally just say the converging nodes are going to attach to whatever node is it's going to look up and down. If it finds one here, then the converging node deletes itself and it becomes this node. This parent now inherits this child. It becomes a split parent because this parent now... It is a parent of this node, but is not the parent of this node. Yeah, it's hard. It's complicated. And then I will just move that to the top of the quote-unquote list. And if we find one down here, I'll just move it to the bottom of the list. I think that's going to be how it works. So node equals rand choice of my not dones. Okay. Yeah, no, that works. So we look up, we look down. Displacement x equals 1 now. Dot now while also sorry, self dot unsorted append the node and remove it from nodes because we haven't actually added it anymore. Now, while true, if we'll default to up, I guess. If It's an index X. Done dot index of node. Yep. True. X is greater than or equal. If done at the node index minus area dot parent does not equal node dot parent if they aren't already siblings. No, I can't do it that way. I have to do it the if node not in if the node isn't in their children. Yeah, that makes sense to me. We can't do it the other way around because, again, there can only be one parent, even though children can have the same parent. Or, sorry, parents can have the same children as another parent. It's just the way this code is going to work. And then we add the child. Now, this add child does not replace the parent if the parent already exists, which is very important. That is incorrect. What I want to do is say not node.addChild.parent.addChild. So now the parent of the displacement node is now going to say, all right, that child is now mine as well, and that should just basically mean that a line gets drawn to that. I have no idea how to visualize this. And then I have to remove myself because I don't want the convergence node. And then I guess I gotta do it this way instead. Search not done. I want to insert that node at the top of it. I have no idea. All right. And then we break here. Thank you. Bottom. Oh. Yeah, and if we go out of bounds, we just break. What's the error? Accept? I do. Or I can do a crash out. That's fine. Okay. Didn't I do that already then? Oh, I didn't. You're right. Thank you for fixing that for me before that was going to be an issue. And -1 chance. That should handle converging nodes now. Oh. Oh, it's not self-done. Not. Hopefully that's not an issue throughout my code. About children, right? Yes. Well, it exists. Again, this is not working properly. Oh, right. I can think of one way to see if this works properly. And it means we're going to have to generate some names. Randomly generated names. Let's go, everybody. So... first... name. Let's come up with some names. Shall we ask ChatGPT? Two. Words E. Okay. see if I can. Oh, I can. Here's a question. This works. There. Heck, my lip. Interesting. All right. So when we... There we are. The name? Label. So, crystal shard. Fuller shard. Okay. So we're going to actually draw this out because I need to see what the paths are. Wow. Depth 0. I'm going to try and write each out properly here. So now I can go to Flame Fang here. There. Flame Fang. Flame Flang. Flame Fang goes straight from there. What I'm going to actually do is back up, go into and see. I'm really banking on this as having worked the first time. I'm realizing now. Oh, Light Rift does not branch to anything. That's just an end right there. Okay, so we're going into Flame Fang next. My god, is that ever difficult to say. Which goes to the Solar Wand. It's 14. Oh, there's a couple. Oh, those are depths, yeah. Or whisper. Some of these sound really freaking sick, not gonna lie. Some of them also don't sound like they... A lot of them actually sound like they belong in Dark Souls. Elden Ring. Wow. This is escalated. Find out how far up this branch has to. Yep. Only a 50 node skill tree. Why am I getting both? Obviously. Just gonna have. Oh, I can see how many we need. Two. Already confused. Six. Splits into... So confused. Shadow Ember... Alright. Thunder Whisper splits into 4 options at depth 4, which gives me Chaos Spiral, which splits into 4 more options. Splits into... Goes into Iron Spike, which splits into 4 more. Which goes into Shadow Ember. Which splits into 2 more. Splits into 1. One. Splits into the 10. Or splits into 1. Splits into 1. Oh, I guess this is... So that would be... This is Light Surge. That's Lunar Scythe. That's Lunar Scythe. That's Phantom... That's Phantom... I'm so confused. I'm gonna draw this out properly now. This might take a long time. I apologize in advance. That's 2 solar fangs that's actually popped up. I don't know the chances of that, but whatever. I don't think it's an issue. I don't think it's a bug. Okay, that's as far as that goes. So, the dream right now would be I can go back to here into Storm Strike and not see Phantom, but maybe I'll if I strike, I see Phantom Echo, which is another Phantom ability. Such luck. I hate how they're grouping these like this. them. Stick pull. Enter the wrong. Am I? Right, solar. Are they? I'm still running into that issue where it's the top one that just has all of them. I think I just don't have enough. Interesting. It's just the maximum of. Failed to generate the tree after 10 attempts. Oh, there we go. Oh, it's become very unstable now. 100 nodes are unstable now? This? Top branch depth is 1. Okay, it works. Apparently, having this set to 0.9 makes it incredibly difficult to make a skill tree. Interesting. if ChatGPT has something. All right. It's using matplotlib. It's its own function. This library before. You have to. Yep. Be one of those libraries that isn't actually called. This I can just self. Oh, whoops. Self.nodes dot data in dot node. Oh. Assuming that the nodes are in a dictionary. Oh. giving me a new function. Which this is just for prototype. I have to redo this for the actual in-game. See what this looks like. Failed to generate the tree after 10. I want more spacing. I want more width spacing. That's actually really good. I like it more. Set this to right here. Width parameter. But not gonna lie, I feel like that's doing a doing. Let's just make doubly sure that it's not doing anything before I ask ChatGPT. Yeah. Well, in general, looks great. What I want to do right now, bump this up. I want to see if the other branches actually fill out. Failed to generate a tree after 10 attempts. I think I know why. And it's, yeah. The issue is that there's only so many skills you can jam into. Why isn't Storm Scythe getting anything? Is it really just the fact that I rolled a nat 1 when getting... fun? I zoom out. There we are. No, this is the exact same. Wait, is the chance just so low? They're rolling that one? Okay, let's make it at least a 1. I need my graphs. Is that the... Three. Yes. Two. Yeah. So after the first one, it's only a 0.6% chance. Great. So what I need is for this to be at least 1 at 1. There. That's actually pretty freaking good. Of 1 point. And that looks good to me. That looks a lot better. Oh, finally. It looks good. All right, I'm going to drop this down to 50. ChatGPT. Oh, I'm dumb. I didn't continue to read. Apparently a width multiplier? Oh. Oh, no, that does not work then. Because I'm not changing this. And I'm calling this function. Yeah, no, I'm not. Is it the issue? Is it an issue of this? Not being wide enough? That's so much nicer. Oh my god. Maybe the width is a little bit much now. All right. I don't think. Yeah, by this level. All right. I've got one more way of discovering if this is actually going to work. And it's not drawing it. I'm gonna run it, but we're not actually gonna run it yet. Generate it. Could just slap a breakpoint in there. Interesting. We never entered it. So percent complete is actually percent complete is 0.4% complete. Chances going to be -1. Okay. Actual percent. Right. Okay. 72% complete. We should have a much higher percent chance of which is this one, I believe. We should be up to point. Oh, we should be up to nearly 2. Did I forget something here? -1. Sorry. The power -2.5 plus percentage. Oh. Oh, does this have to be whole numbers? So percent complete. Um, I could just multiply this by 10, and that would give me a value between 0 and 10. That would bump that up to a 7.2, which would put me at the right value. Okay, I was not having any convergence. That was an issue. Oh boy. Oh, that's the wrong. Oh boy, I sure hope this doesn't cause any problems. Oh my god. Did a thing. Let's turn on drawing again. I doubt it will do much, but let's see. I won't be able to see when the converging happens. Interesting. That's a lot of error. Well, in that case, we'll just do what we were about to do before, and we will take a look and see what node is going to be replaced, what layer it's on, and stuff like that. Like, what its parent is currently, and stuff like that. Okay. Oh, wow. So, Dark Strike is going to be replaced. Sorry, Blazing Ward is going to be replaced. And it's going to be put back into Unsorted. Yeah, now we have 20 dependent, so I assume it's this one here. And now we remove it from the actual sorted nodes. So now it looks both up and down to see what parents it has access to. So, Star Vortex, who has Crystal Rift as its parent. Blazing Ward had Eternal Claw as its parent. So, I don't know what layer this is. Oh, my parent actually has 3 children, apparently. Void Wrath, Dark Strike, and Blazing Ward. So it looked up because it was this is actually the first one in this list. It looked up and saw a compatible node that it could link to. Um, Why? I don't even think I remove, right? Oh, no, I do. I don't want the node, this node to be in there anymore. I want the node that I'm looking at to become my child. Yeah, that's what this is. So we are grabbing this one, which is Star Vortex, which has a parent, uh, which is the Crystal Rift. So if I go, when this runs, if I go all the way to Crystal Rift, the way I'll know that this works is if I find Eternal Claw, will go into node index -1, right? Yeah. Star Vortex. And then Star Vortex will back into Crystal Rift because Crystal Rift is its parent. Whoops. God damn it. Whoops. Okay. All right. I immediately found another one. Okay. So erase this. So my node is Flame Shirt. That doesn't matter. What matters is the parent. Mystic Surge. Will now go into. Well, this is at power level 3 too. A very early one. Wow. Will now go into 4-1. Shadow Rift. Which will then go back into whatever Shadow Rifts is. Void Fury. Okay. Now get rid of that. X not in. Why is that now happening? Now it didn't happen. Yeah, whatever. Now it didn't happen. That's really weird. Yeah, let's... Oh, try that again. Am I putting the breakpoint again? Here? It'll work. Alright. Chaos Spiral. Into 4 minus 1 3 Iron Whisper. Back into... What? Is that a different Chaos Spiral? What are we? Eternal Wrath. What's the parents? 22B19 B9183, whatever. Iron Whisper. They're both of the same. If no, not in X X. Oh, 3. Iron Whisper, parent. Chaos Spiral. Oh, it's not in here. Oh, because I've just removed it. I mean, in the best case scenario. Yeah, that didn't crash anything because in reality, I just removed it and re-added it to the child or to the parent even. But why? If the node is not in the parent's children, okay, Storm Nova is at 5. 5 minus 1. It also has Blazing Nova. Parent is Dark Echo, and its children are... Five is Storm Nova, 4 is Blazing Nova, and its children are Storm Nova. So let's see if this one actually enters in here, because it shouldn't. This node is Storm Nova, and its parent is... That makes sense. Yeah, that makes sense. If I... I open up your children, Blazing Nova, Storm Nova. Yeah, okay. We should not be entering, but we are. Why are we entering here? This means this still doesn't work. Because it's most of the time just going to draw to its. Oh, wait. No, I'm not looking at the parent. Dot parent dot children. I think that's better. Oh, if this crashes. Didn't crash. I don't know what actually happened, though. It should be running. I think? Yeah, it should be running. But I didn't get anything. Also, not able to type. How did we... What broke? Oh! Right to file broke. That's quite honestly a possibility of that happening. Dark Strife goes into Wrath. Let's do the thing we were doing before and actually just see which one is being. Okay. Okay, there we are. So this node, which is Crystal Claws, I don't care about that. Eternal Whisper. Wow, that's all. We'll now go into node index -2, just 3, -2, Stormclaw. Which will then go back into its parent, Shadow Ward. Okay, now we have to find Eternal Whisper. There? All right. Eternal Whisper into Stormclaw. And now if I back out, I should be in Shadow Ward. I am. Oh. Oh, finally. So we have convergence working now. So now we have skill trees that actually branch out and then come back to one another. That is huge. Back out of this. Okay, there we go. This is just broken. Don't know what's going on with it. We need to update this right to file. Or node in self.nodes if node.parent. So if the parent exists, we write the label to write the parent label to then that's not gonna work. It's just not. I'm gonna have to actually make this thing work again. This actually worked quite well. Um yeah. I'll have to think about that a little bit. Um I just have to do a little bit more put more thought into how this whole thing is going to work. I guess this one on the bottom doesn't look horrible. Especially if I don't have these jagged lines. If I just had straight lines, this would actually look not the worst. And if I could affect this spacing based on the width of this. So there are some ideas. I think I'm going to call it there, though. We've had a very productive day. We now have skill trees that can just be automatically generated and randomly generated. There is a few mishaps, I think, but they're few and far between. Oh, remember how I said they're few and far between? Oh, this one failed to find a node to converge to. Interesting. Failed to find a node to converge to. That should never happen. Why is that happening? In theory, there should always be a node to converge to. Yeah, I can... because they're both now deprecated. Ugh! This is fine, but... it's fine. It's not. Breakpoint. Real quick debug. Node index is 1. Displacement value is 2. Let me take a look at this. Not done. Right. Chance is 1.85 right now. And parent nodes available is 3. What are these parent nodes? Frost Ember. Dark vortex. And dark blade. So where's not done here? Why is that the same? Parent node's available. For node and not done. If node.parent and node.parent not in, parent node's available. Oh. Sorry. There. That might actually fix it. Failed to find a node to converge to twice. Node index minus displacement. So 2. Node index is 1. So first things first, let's see if there is a node to converge to. Parent Shadow Ember. Shadow Ember. Crystal Echo. What is my parent? 1. So I am Lunar Echo, which has the parent Shadow Ember. Directly below me is Light Vortex with a different parent. Why am I not able to link to you? If node index plus the displacement index is less than the length of not done. I should have seen this when I did +1. So start. Alright, let's take a look at this real quick. Frost Rift. Not done. There's 3 items in not done. We're looking at Frost Rift, which is at 1. So I should be able to connect with Echo. I should be able to connect with This is the exact same thing that just happened. I should be able to connect down. Oh, wait. I entered this. Crap. Crap. Oh. It shouldn't be an issue. See if that works. I have... Actually, I don't. Oh. This is apparently an issue. Okay. Okay, node.parent. Ah, no, because I should break. Yeah, I should break. So node, just spiral. Uh, Parent. Is it light spirals? Have me in the. Hello, why are we here? The node index is 0, which is Storm Ember. Why are we just to suffer? Current nodes available is not possible. Okay, let's solve this issue first of how the heck are we getting in here when we only have we only have one parent. We only have one available parent because in not done there's 2 items, both of which have the exact same parent. Yet up here in parent nodes available, it says we have 3. Flame Pulse, Dark Scythe, and Blazing Spiral. So where did they all go? Okay. This is chance is now 0.32. Available is 3. Is that true? Done. I can believe it. Parent nodes available is now 4. Or not. Yeah. I guess I could just watch. Just a link. Done. Three. Tricky. Take a look inside the... Hold up, hold up, hold up, hold up. Sorry. Yeah, there is a little bit of an issue. I have a 1.7% chance to merge, but I only have 2 available parents. So... Um... If the length of... sorry, let me think about this here. Is that the issue here? It's that... Because we have 2 parent nodes, only 2, when this one is marked as a convergence, it's going to link this and this. And what happens if another one's rolled? It would be this one, and then that's going to link to there as well? Or it would be this one, which is now going to try and link to here? I think it's going to have to be the fact that, like, if we merge, there has to be... If the link available plus 1 is less than the chance. Yeah. That way, if it's 1.7, then I just drop it down by 1. Do this as well. Oh, maybe that was actually the issue. Try this. Try this again. No, we did fail to find a node to converge on here. The issue, I guess, lies if this actually happens. Because then this becomes this. But now what happens if this tries to converge? It has no options. And that can happen here too. So this converges here. This converges here. Now what? Now this one could be chosen as convergence, and where is it going to go? Unfortunately, without doing a crap ton more code, I'm going to have to just throw a band-aid on this. There. That will work. It's a rare thing to happen. Oh. Yeah, this is the same issue. Okay. We're going to just brute force this a bit. Just going to forcibly try and create that crash. Really hate that it keeps selecting that. Whatever it is, it's rare as well. There it is. So it's Mystic Fang and Iron Aegis. And Iron Aegis's children are... Oh, that's useful. Something correct. It's the last bug fix I do before we end the stream. Done a lot. kidding me? The dang crash. There it is. Mystic Rift. Infernal Surge is apparent. Mystic Rift is not in that list. Expensive? Oh, got it. Node. Flame Ember is not in either of those. Parent. Is it an issue of... I think the fix to this is just making it so that nodes can have multiple children. Is the only issue. Oh, yeah, look at parent nodes available and length of not done. There's 2 nodes inside that not done and 4 in the parent nodes. So what's happening is a node is being set as a node is being merged and then set as a different. Yeah, that's what's up. Okay, so to do right up here at the top. Fix the visualization. To do give nodes access parents should fix multiple convergence, which it should. If we do that, because what I think just is causing this crash right now is what's happening right now is this one's being marked for convergence. It's great. It now looks like this. Cool. Now this one is being marked for convergence. And it doesn't like the fact that now both of these parents have to have it removed and be added to... Oh, sorry. It doesn't like the fact that this parent is being told to have it removed, because that's what I'm doing here. I'm saying remove the child from this parent because this node still thinks that this is its parent. So that I can have this line. But this node, or sorry, this parent has no idea who this node is. No, sorry. This node thinks that this parent is now responsible for it. Actually, right. What does my child... Oh. It's this. This is the issue. I remember now. This child is not a child of this parent right now. In fact, I don't know. Yeah, it's not. No, it is. Oh, am I forgetting to remove? Where is not done.remove? It's way down here. Do I that up there? Should be fun. I'll have to do some more research into this then. Because it should actually work. It's not the issue that I'm thinking it is. So this node now it doesn't need to know both its parents. It only needs to know the one that it needs to back into. So, which can be this one here. That's absolutely fine. Both of these parents have this child as a child. Or should. But this node, Flame Ember, I'm willing to bet has no parent nodes. If I go up to parent, Flame Ember does exist. Oh no, it's Radiant Ember. Right? No, it's... Oh, right. Yeah. Flame Ember... is not a member of this. Why is the length of not done 2? It's only got Flame Ember and Solar Fang in it. But it should be way bigger than that. Unless, no, this has one child. This is one shot. Polar Fang. Also, none of those were Radiant Ember. So, Radiant Ember got lost somewhere on the bus, apparently. This is a very rare bug as well. I don't know what's causing it. Alright. Next time I'm just gonna absolutely slap a bunch of prints all throughout this section of code so I can see what's happening in real time. Well, I say real time. I can get a perfect history of what's happening. But that's for next time. That's for next week. I'm gonna end now because my brain is frying and I don't want to break stuff. Excuse me, sorry. More than I am already. But that was very constructive. We've got the 95% of the way through making our skill tree generation. There are going to be more rules and stuff that I have to add, but for now, this is actually extremely nice to have and to have visualized with this visualization that I immediately broke. But we'll fix that next time. So thank you all for watching. This has been fun. I will be back next week. I don't know what my next schedule is going to be because I lied when I said I was going to make it on Wednesday, and instead I did the TTS bot. But I think it was a good use of my time. Over the weekend, I will make up the new schedule and I will post it. It's going to be the same days. It's going to be the same hours. It's just a question of what games we play. Yeah, I will see you all then. Have a great night, everyone. Bye-bye.